So what's the lesson objective today? We're really going to be talking about scaling and high availability. Trust me, this is like it's like a backbone. It's like a backbone to the cloud because honestly, when you see people move to the cloud, scale is one of the reasons. Remember, we said it at the beginning. Scale is one of the major reasons why people go to the cloud. Scaling, the ability to scale, meaning on premise. We you remember we talked about how difficult it is if you wanted to scale, that you needed to buy more machines, you needed to set them up. But the fact that you can do it easily in the cloud is why people move to the cloud. So we'll see scaling and what high availability looks like. So as part of this module, we are going to look at elastic load balancing. We'll look at auto scaling. We'll look at what fault tolerance means, right? When you hear the word high availability, that's really fault tolerance. You see what that means. And then we'll look at things like scalability, elasticity, and agility. We'll just discuss them as a concept, okay? So what are some of the concepts you need to know at this stage? Scalability is one of those things, right? Elasticity is one, and the third one is really agility. Agility, I don't need to talk about it because agility, we've talked about it before. It's just being agile, right? So if you, I don't know if you are non-techie, you probably might not know. You might not. You may. I don't know what experience you might have with agile, but if you are in the tech world, agile is a framework. So agile is just the ability to move fast, right? So it's not a word that is typical to cloud alone. It's used in different places, right? But it's just the ability to move fast and just the ability to also adapt. You can change quickly. So that ability to change and move fast is just being agile. Okay, so someone is saying agile methodology. Okay, so it's kind of different from scalability and elasticity in the cloud. Okay, so first of all, scale itself is your ability to basically increase your workload, right? So your workload can expand to more or less like handle your traffic. So when you think about it, that's just the word. When you talk about scale is just your ability to. But again, now, if you look at it in the concept of compute, your ability. Think about it. I know how we usually test our EC2 instances since when we started. We'll just go to the UI and test. But in the real world, it doesn't work that way. You probably have millions of requests you are handling in 1 minute or in a second, right? So your ability to handle that increasing workload gracefully is really scalability. Okay. Now, I will explain the different kinds of scalability that is out there, but two major ones is vertical, right? Scaling vertically and also scaling horizontally. And don't worry about this first slide. The next slide is going to explain it beautifully well, okay? And then elasticity is basically, you see automatic, I put automatic in caps, meaning that a system that is already scalable, right? Once you make it automatic, meaning it can scale based on an event or like a real-time event or like a pattern, right? It becomes elastic. So that's just the difference. If you ever were thinking about what is the difference between scalability and elasticity, just know that elasticity is built on top of scalability. It's just automating. The automation that is added on top of scalability is what gives it elasticity. Okay. So the two can be similar, but if you understand it from that point, so scalability is just your ability to handle as the load is increasing. Any system that can handle that load is already scalable, right? But if it is elastic, it means that it can now do that based on an event automatically, right? So we're going to see what that means. Let's now see the screen that I have, this slide. So I said vertical scaling, right? So if you look at vertical scaling, look at the left. A small car, is trying to drag like a very big tank. And you can see there's a lot of smoke coming out of the car, right? It shows that it is doing a lot of work trying to do this task. But we know that it will just struggle. It's not going to do it. It's really not going to do it. It's not going to get it done because that car is too small to move that tank that you see there, right? So what is a better way to do it? Go and get a bigger truck. So you see the truck on the right just carried the tank easily. So you see the fact that you move from that small car to a big truck. That's vertical scaling. And the whole idea is that you are basically scaling up. So the car is small. It really cannot do beyond what it's made for. And for that reason, you are scaling to a bigger car. So if you think about it, you are changing the car for a bigger car. So that car probably has a bigger tire. It has a bigger engine, So when you think about it, you would see it, physical comparison. The small car is way less in compute or is less in capacity than the big car. Okay. And honestly, the same concept is similar to the cloud. So if you have a machine that is 1 CPU, right, and has 2 GB of memory, and it needs to do something, and the thing is hard for it to do, right? One way to do it is just basically, maybe it's lacking memory or it's lacking CPU. It can't really do what it has to do. One easy way of doing it is just basically get a bigger machine, right? A bigger machine, a machine that has more CPU, a machine that has more RAM, and you get the job done. But you can liken it to this problem that we have right now. So that's vertical scaling. You physically upgrade the machine. So if you think about it, a machine has one CPU, 2 GB RAM. It's trying to do work for you, but it cannot do it. And because it doesn't have enough CPU, it doesn't have enough RAM. And then for that reason, you are scaling it up. That means you are giving it more CPU and more RAM, just the way we are changing this car for a bigger car. That's vertical scaling. What about horizontal scaling? Horizontal scaling, the same problem that we looked at, you can see it in a different way. Okay. What if we wanted to use that same small cars, that small car that we're using, we still wanted to solve it using the small car? Okay, it's possible. Maybe you just might need 50 of those cars or 100 of them to stack a rope around the big tank and then pull it over, right? So if you think about it, in this case, you are scaling horizontally. Okay, the whole idea is that you pretty much might be using small cars, right? But you are using more of them. Like you can use 100 small cars to achieve the task. Okay, and you'll not be asking me, why should I use more cars instead of just scaling up to a bigger car? The issue is that if you look at this problem where we have here, have you ever thought about what would happen if this tank was so big? There is a limit to where the image on the right can scale up to, right? So think about it. Maybe you have a problem and you're trying to solve it, and you've increased it, you've added a bigger machine, more or less like a bigger car, and you're still trying to move that object, but it's getting difficult, right? And you get even a bigger. So vertical scaling has its limits. That's just the issue. It has its limit. But if you think about this problem and you try to approach it in a different way, and you say, okay, instead of continuously going up to get a big car, why not use smaller cars and get a lot of them, right? Because it's easy to get small cars, but it might be hard for you to get a very big car with so much capacity, depending on the problem you are trying to solve. So that's where horizontal scaling comes, right? So both of them are trying to solve the problem. It's just that vertical scaling, there is like a limitation, because why? There's just an amount of level you can go in terms of like getting more capacity, getting more resource on a particular entity, as opposed to just having almost the same resource but scale on the horizontal, right? Get more of that, because it's easy for you to get small cars and get a lot of them, but if you continue to scale up, it might be difficult for you to get a very big car, right? To do the problem. Honestly, it's the same way in the cloud. I use that just so that throughout your journey, these things are things we are going to see, whether it's in elastic scaling. As time goes on, when you start seeing EKS, you start seeing other scaling, other compute scaling, right, in the cloud, you begin to see that it's similar. So when you ever think about vertical scaling, in this case, it's just increasing, right? Increasing physically, like more or less like the physical capacity, just like how we moved that car from the small car, we changed it, we swapped it for a big car. It's the same way you can do that. So for T2, for example, we've been using T2 micro for our test. If you feel T2 micro is not solving your needs, you can move to a T3 large, right? T3X large. If you check that machine, the CPU will differ, the memory will differ, okay? But when you don't think about horizontal scaling, you are really increasing the number of EC2 instances. So it's like you are using the same T2 micro, but you're using a lot of them, right, to solve a similar problem, okay? And that's where the concept of auto scaling and load balancing comes in, which is exactly what we'll be discussing today. But it's good I set this foundation for you to see, okay? So this diagram is also here, and it just basically compares both of them. So the one on the middle is talking about horizontal scaling. So I'm trying to do something with one EC2 instance, and it's not working. I get more EC2 instance. I get more. That is made possible maybe with an auto scaling group or a load balancer, right? And I'm going to show you. But on the extreme right is vertical scaling. So I'm trying to do something with a T2 micro. It's not going to work because it doesn't have enough CPU or enough RAM. Then I switch it to like a T3 large, right? And if it still doesn't solve it, I can move to a T3X large, right? So I can scale in as much as it supports me. But you should understand that there are some problems that vertical scaling will not solve. Like it's not going to solve. You can't solve it easily with vertical scaling, because why? There is a threshold you reach that it might become very difficult, right? And that's why there's horizontal scaling. Although there are some problems too, you see, the only way to do it is vertical scaling. Just know that in the cloud, not everything supports horizontal scaling. There are some things you see as time goes on, you see that you can only scale them up. Some of them you can't really scale them horizontally. You can basically just change to a bigger instance. Okay. So if you think about it, vertical scaling, like I said, you just need to increase the resource. Horizontal scaling, you need to add more resource, basically just add more instances, right? But again, I said vertical, there is a limitation that can come from the instance, right? Because think about that first problem that I showed you. If you have like a big object that you needed to move, there may not be a big car that has already been manufactured that can solve that problem, right? But there might be small cars that you can just assemble a lot of them and get the same problem solved, right? And then if you think about it, vertical, there's just one single instance, right? But when you do horizontal scaling, it means that you don't have one point of failure. It means any of those instances can actually can help in solving the problem, okay? This is just more details, basically. So if you think about vertical scaling, it's really a simple upgrade process, right? You basically just upgrade it. But horizontal scaling, there is more involved, because your application has to be built around, your application has to be built to support it also, right? And then if you think about vertical scaling, it's minimal. You just need to change the instance type, right? But when you think about horizontal scaling, like I said, your application has to support it, right? And I also said that fault tolerance for vertical scaling is really one point, just a single point of failure, because why? You are increasing a machine that is small, you are making it big, right? It's still one machine, right? But when you have more machines doing it, it means that even if one machine fails, others can still carry on the work. That first image that I showed you showed so many cars trying to pull a big object. So even if one has a fault in its engine, others can still pull the load. Okay, that's one difference you need to see. And I said, if you look at the scale limit that I mentioned here, hardware, like there's a hardware maximum, when you think about it in the EC2 world, right? But even cars, there's a capacity limit they will get to. Probably is going to be hard, right? But or on the other side, you can pretty much add more instances, right? And just do more. Okay. Usually, vertical scaling, there's also something that's common, downtime, right? Because let's even look at the other pictures that I showed at the beginning, right? If you think about the fact that you needed to change to that big truck, right? That means you have to stop work, right? You have to go get the new truck and just, set it up and use it, right? But if you think about the other ones that had so many cars that were doing it, you can continue to just swap out some of those cars and the work will still continue. And it's the same way with EC2 instance, okay? So usually for vertical scaling, sometimes the downtime is required, but for horizontal, anything that supports horizontal scaling, downtime is not. You won't downtime won't be a problem. Okay. So now let's talk about more times. Now that we know that you can scale vertically and you can scale horizontally, right? We'll now focus from now on to because vertical scaling we already know what it is. Anytime you see yourself going into your console, you are changing your EC2 instance from T2 micro to a T3x large. You are doing vertical scaling. So that one is not. It's easy. We don't need to stress about it. Um, what is now horizontal scaling? When you think about some of the benefit that comes in, one of it is high availability, because if you have instances that if you have more than one instance, right, that can do the same work, it means you can spread them, right? You can spread them. I think we've already learned the concept of regions, availability zones, right? So it means that you can put some instances in one availability zone, put some other instances in an availability zone, right? What it means is that your application becomes functional for the most part, right? So the fact that you just have more than one instance that can solve the problem, it means that your system is guaranteed to be highly available. The word highly available is just the fact that if one goes down, there is another one that's like a backup. It's not even a backup. It's like a partner in the job that can continue the work, right? So that's the concept of high availability. And as you grow in your journey, you need to start differentiating these terms, small. Like high availability is the fact that if one goes down, right, there is still another one to get the job done. But it's different from fault tolerance, right? Because fault tolerance could just be the fact that one is in one AZ, right? And it means that even if that AZ should be impacted, maybe there's a problem, right? Another AZ can handle it. So AZ in this case, let's just say it's a data center. So you have some in one data center, and the data center, something happens, something goes wrong. You still have instances in another AZ that can continue the work, right? So it means that your system is fault tolerant also. You see, and I also mentioned there that you can achieve these things by geographical distribution, redundancy, and then the use of automation, right? So whenever you see, like in your exam, the commonest things you see is multi-AZ, right? Multi-AZ is brought about, horizontal scaling is what empowers multi-AZ deployment, right? So a workload that supports horizontal scaling, those workloads can be in different availability zones. And that's the concept of multi-AZ deployment, right? You can deploy some in one AZ, deploy the others in another AZ, and then it's one single workload. But you know that if one AZ should have problem, another AZ can do the work for you, okay? So, and load balancing, auto scaling are two things that you use alongside that multi-AZ deployment just to get the full result, okay? So let's now talk about load balancing. Remember at the beginning, this is similar to what I drew in the beginning, but I was just trying to show you the journey we've taken to get to where we are right now. We have an account, we've learned how to provision access to the account, we already can do that comfortably. So far, so good, we've been creating just single instances, but in the cloud, it doesn't work that way. It can't be one instances, right? In most part, there'll be more than one instance, right? But like I've always mentioned, if you think about it, if you have like 3 instances and somebody has to, right now, I know how we usually test. We'll go to the URL, we'll take the IP address of the instance, we'll put it on the browser. You don't expect real applications to work that way, right? Most times you go to a domain, that's how you are reaching it. But behind the scene, there's a lot that goes in. There's a lot that happens, right? One of it is really load balancing. So whenever you go to a site, you go to google.com or you go to any site, right? Usually what you see is a simple URL, but behind the scene, there is really a lot that is going on. It's probably there's a load balancer there that is distributing your traffic or whatever request you are making to some backend instances that is servicing the load. And backend instances for now, we'll be talking about EC2, but honestly, there's more to it. It could be that when you go there, there are different compute backend that is handling it. But all that is made possible by there's some sort of load balancing that is happening. Okay, so just think about it from the simple term. It's just something that takes in the request and distributes it based on the backend that it knows that is willing to accept the traffic. So in this case, It's a very simplistic example, and I'm using EC2 instances, right? Because that's what we've been doing up until this point. We've been creating EC2 instances. Okay, so if you ever think about distributing traffic around multiple instances, EC2 instances that you create, that's where a load balancer comes in, right? So what are the benefits? It prevents really single server overload, because if you have just one server that is responding to your traffic, at some point that server might not be enough. It might not be enough to handle your traffic. But if you have the load distributed across other instances and there's just a load balancer that is taking the traffic, you can distribute it right and spread it evenly across your workloads. Okay. And then health monitoring is one thing that you also see. The fact that if one is bad, like if one of these EC2 instances that you see here is bad, the load balancer is smart enough to remove those ones that are bad or that are unhealthy and remove them from the pool, right? Such that they are not sending back, they are not part of the pool of the compute that is responding to the request. Okay, so health monitoring is something that you get out of the box from using a load balancer. And also, like we said, it prevents one single point of failure. Okay, so in the concept of, as far as AWS is concerned, a load balancer is fully managed. It's fully managed, right? So the underlying infrastructure from that the load balancer uses, AWS manages it, right? But you are guaranteed that it's always going to be there to help you distribute your traffic, right? So it's fully managed. It's a fully managed service. So it's not a load balancer that you install and then you have to manage yourself. No. And then it works across a lot of, as time goes on, you begin to see it integrates with a lot of things, right, inside of the AWS ecosystem. But one of the commonest one is really EC2 instance, because sometimes you have multiple instances and you just want one single point of entry, right, that can distribute load to those EC2 instances. Okay. As we'll see, as time goes on, also there's a lot of security integration, right? You can place so many AWS security services on top of the load balancer just to make your application secure in the cloud. Okay. You can also monitor the health of your load balancer. I'm not going into details here, but just so you know that as time goes on, this is how you now grow, right? At this point, you're basically knowing what's a load balancer, what types of load balancer are there. But as you grow in your journey, you begin to realize that, oh, it's not just about having a load balancer. It's also securing the load balancer. It's also monitoring the load balancer to see, get useful metrics. Okay, like how many people are reaching my application at a minute, like in every minute, those kind of, you can also see latency, right? You can see how long is it taking for my load balancer to respond, right? And then you begin to also, with time, you will begin to talk about DNS to see that, oh, it's possible in such a way that if you make a request to a particular URL and, whatever backend is servicing it is not working, you can reroute to another route, right? So, and that's where DNS failover is going to come in as time goes on. But just know that at this point, you are still just, understanding the services at a basic level. But as you grow in your cloud journey, AWS cloud journey, you begin to see all these other areas. Okay, so sometimes it's worth mentioning them. So you may not pay attention to the items, but you should pay attention to things like, just know that there will be DNS integration as time goes on. There'll be monitoring, there'll be security around your load balancing, okay, in the cloud. Now, usually I know you will not see a lot of this online, but I did put it in this slide just so you understand. It will make you appreciate the different load balancers that are out there, okay? Because there are 3 major load balancers that we're going to be discussing on this call, and a lot of them will not make sense if you don't really understand this. I know if you don't have like a tech background, it might be difficult for you to look at this diagram and understand it. But just know that every time you make a request to a browser, like you go to a site and you type, right? That's what they call the open system interconnection, which is the OSI model. Is the fact that your request actually goes through a layer. It goes through several layers to get to the destination. Okay, so the application layer is really level 7, which is more or less like that's where the human is interacting, right? So when you go to the browser, have you thought about sometimes you've gone to a site before, and when you go back to that site, automatically it pulls your data. You didn't have to log in, right? It knows your session. Because it uses your cookie, like the cookies that are stored from your browsing, right? It knows some of the places you visited last. All that is the application layer. That's the most times the layer you interact with, right? Your sessions. So there's a lot of things that happens at that layer, but that's really most of the things people care about. But outside that layer, there are more layers, okay? And we're not going into detail. That's why I put a link in there. If you are ever curious, you wanted to read more, you can go and look at it. But one thing you should notice is that apart from the application layer, which is what most people are used to, in there is also a transport layer, right? There's also a transport layer, which is layer 4, and most people don't really relate at that level, right? And also even there's a network layer, and there's even a physical layer, okay? So this is it's not a networking class, so I won't be able to go down, but just know that these layers are there, depending on how, if you look at, because whatever when you interact with the site, it's actually a network. It's a network, and within that network, there are different things that happen, right? And depending on what they are doing, that's how you break them into layers. So like there are physical layers, where you're talking about like the physical, more or less like the physical medium itself that exists on that network. But you, for the most part, most of us on this call, we're used to layer 7, which is like your session, when you interact with the application. Okay. So just so you know, and it's here in your slide if you wanted to get more details. Okay. If you were doing a networking course, you would have to break this down to understand the different layers that are out there and what they do. Okay. So now that we know that there is an OSI model, right? What are now the load balancing capabilities that we have in the cloud? In this case, AWS. There are really 3 major ones. So the one that is written on the bottom is already been phased out. It's called the classic load balancer. So the classic load balancer was really the early load balancer AWS had. So just so you know, the diagram that I showed you before, it provided like a load balancing capability for you to operate both on layer 4/layer 7, right? But all that is gone now, so you don't need to bother yourself again about the classic load balancer. AWS is trying to phase it out. Okay, so right now you really need to care about 3 kinds of load balancer, and those 3 load balancers are depending on what you want to do in the cloud. Like I always tell you, that's the beauty of the cloud. There is so many options for you to do the same thing. Okay, nobody boxes you into like you are not boxed into like just one corner. It depends on the problem you're trying to solve, right? So like we mentioned, like I mentioned before the slide, there is really the application load balancer. It's popularly called ALB, right? It operates at layer 7. Okay, so the layer 7, the OSI that I just shared, there's really a load balancer that simply operates on layer 7. And the good thing about that kind of load balancer is the fact that you can now do things at that layer, right? So you can more or less like, you can redirect. There are some things that are very common to like operating at an application layer. Things like, your cookie, things like your understanding that it needs to redirect. You can do that with an ALB, okay? And most times the protocol that's working at that layer is really HTTPS and even the WebSocket protocol, okay? But if you wanted to now go one layer below, maybe your application, you don't really need session management. You don't really need to redirect people. You just basically want to work on at the network layer, right? That's why there's a layer 4 load balancer also, right? And it's popularly called a network load balancer. Okay. The protocol you're going to see there is TCP, TLS, UDP. It's really a high performance load balancer, and the reason is just because it's not doing all the things that a layer 7 load balancer is doing. Okay, layer 7 keeps track of, it understands, you can use cookie, you can do path. It is doing more, right? So it can't be as fast as a network load balancer, because a network load balancer is basically operating at layer 4, right? At a network layer. So it cares less about something. So it's a high performance load balancing option if that's what your application is looking for. Okay. And there's also something that works at layer 3, which is called a gateway load balancer. Okay. And you're going to see it as time goes on. But one thing you notice is that in the cloud, sometimes you may want to analyze your traffic. You may want to analyze the packets that are operate like I said, if you look at our OSI, it's at different layers. But if you look at layer 3, that's where you can actually now see raw packets, right, of the traffic itself that you don't see from a user perspective. There are sometimes you want to analyze that. Maybe you are trying to check for vulnerability. You're trying to analyze a pattern, right? If you needed a load balancer to help you operate at that level, that's where a gateway load balancer comes in. Okay, so at this level of cloud practitioning, nobody would expect you to go really into details, right? But just know them at that layer. The fact that one is a layer 7 load balancer, the other one is a layer 4 load balancer, and the third one, nobody will really ask any question around classic load balancing again, because AWS is phasing it out. So the 3 questions you see most times are going to be around the 3 types of load balancer: ALB, NLB, and gateway load balancer. So let's talk about the application load balancer. I'll just briefly just touch on it. Like I said, it's really layer 7, right? Layer 7 is really at the application layer, right? So it cares about things like HTTPS, HTTP. It can do things like routing. It's intelligent enough to do things like path-based routing, host-based. It does like you can build a lot of routing logic around it, right? And that's why it's operating at layer 7. Okay, and that's why at that level it may not be as fast as like a network load balancer. Okay, so it also has like HTTP 2, the new HTTP protocol support. And the good thing about it is that, as we are going to see on the call, because we're going to show you one, like I'm going to show you an example. One thing you see is that one thing that is common about an application load balancer is that when you deploy it, it gives you just one single DNS, right? So more or less like a DNS endpoint, such that if you click on that DNS endpoint, you can resolve all the compute that is behind it, right? So let's assume, like you can see on the diagram, there are users on the left trying to access your application. Instead of reaching the EC2 instance directly, they'll go through a load balancer, and then the load balancer will distribute the traffic to all the EC2 instances that are behind it, right? So it is the load balancer that will know the EC2 instance, right? And then the end user does not need to know each of the EC2 instance because the load balancer is doing that on its behalf. Okay. These are some of the details you see. Basically, there's a concept of health checks, just for you to, you can configure health checks that tells the load balancer when the particular EC2 instance is healthy or not, right? And you can also decide how often you should be doing the checking, more or less like checking the machine to see is it healthy. It's like you are pinging the machine just to know when to remove it. If it's an unhealthy machine, any request that goes to that machine is going to fail. So the rule is you're always doing like a check to see is it healthy. If it's healthy, leave it in the pool. If it's not, you can take it out, right? So that's the whole concept of health check, right? And there's a concept of target types too, right? You can have like what you are targeting, whether you want to reach, right now we'll focus on EC2 instance, but trust me, as you grow in your journey, it's not just EC2 instance. You can route from ALB to other types of backends, okay? And then health check is obviously there. You can, as you will see, you can decide what is healthy. It's you that will define it. Okay, there is no golden rule, as you see as we go on this journey. And let's now look at network load balancer. So, like I said, it operates on the layer 4, right? So think about it that layer 7, there's a lot of application-related logic that the load balancer will be doing, and that's why it's not as fast as the network load balancer. The network load balancer is very fast. Okay, very, very fast. And the reason is just because it's not doing all those extra things that you are doing at layer 7. It's basically at the network layer, right? So low latency. And honestly, when you go to the exam, especially at this level, the questions will be you'll be asked exactly more or less like if you're looking for something that is very, very fast and does not really care about, like, you don't care about routing, you don't care about sessions. That's where network load balancer comes in, because at that point you don't really care about, you don't know those things and you don't care about them. Okay. TCP UDP is the protocol that will be common there. The other one we said HTTP HTTPS, right? Here TCP UDP. And as you can see, it's similar, basically similar to the diagram that I shared before for an ALB, right? It still uses going through a particular using a particular kind of protocol, right, to hit the network load balancer, but it's also being distributed to a backend, which is in this case EC2 instances. But it's the same concept of a load balancer, right? The fact that it is receiving the traffic on your behalf and it knows what is behind to service that traffic. Okay. So what about a gateway load balancer? A gateway load balancer is a bit different. It's a bit different how it works, but you just need to look at the diagram. Just know that whenever you see in your exam, and the thing is that not just at cloud practitioner level, as you grow, you will see gateway load balancer is something you cannot miss, especially if you go into advanced networking. When you start touching areas like that, you have to know gateway load balancing. But what it is, like I said, it operates at layer 3, right? So it knows it can more or less like load balance. So the thing is that if you look at how intercommunication happens, there is a layer called layer 3 where you can see those raw packets, right? So what a gateway load balancer does is that if you have like an external tool, like I don't know if it's showing properly, so I probably need to remove this diagram, image, so I can see what is there. Maybe I can just hide this. Just give me a second, please. I think I can hide this text. Yeah, I can hide it. So what happens at that layer is that you have like a set of packets, right? You're at layer 3 and you want to analyze them. And you have like a third-party appliance, like a network appliance, right? That can analyze that for you. So what a gateway load balancer can do for you is that if you have a lot of those appliances, a gateway load balancer can take the traffic to those devices, load balance it between those devices. And then depending on what you want to do there, it could be something that is doing checking for intrusion detection. It could be something that is checking to see if there's something strange that is happening within your network, right? It could, it can actually do all that and then decide if the traffic is a good traffic, and then that's when the traffic is passed to your application. So in this case, the only difference, if you look at this diagram, the diagram before the let's go back to the previous diagram, this one, you can see that the load balancer is targeting EC2 instances, like it's targeting the compute. But the second type of load balancer is not targeting your compute, rather it's balancing all the packets sent at the IP3 level through some set of third-party network appliances. Depending on what happens there, if there's like a filtering rule, whatever happens there, if it succeeds, then that traffic is passed to your application. But think about if it's a lot of packets, right? Something needs to load balance it around the appliances that are using it, right? And then from there, you can now decide if the traffic should move to your application or not. Okay, so just know that load balancing at this level, you are not load balancing against your application. Rather, you are load balancing against the traffic at layer 3 through a virtual appliance, which in most cases is just to more or less like do more interrogation on your network, right, to find out if there is something wrong. Okay. So like I said, distribute traffic across a fleet of security appliances, right? So it's usually useful. So whenever you hear like the Geneve encapsulation, or anytime you hear anything around Geneve, because those virtual appliances that I mentioned, they have to support that Geneve protocol, right? So whenever you see your exam and you see Geneve, just know that you're talking about a gateway load balancer, okay? but you just need to know how it operates. The fact that it's not really load balancing against your EC2 instance, rather it's load balancing against like a virtual, a third-party security virtual appliance. Okay. Um, and then, so as part of one thing you see is that when you're configuring a load balancer, security group is one of those things. So I know we've seen security group, so it's not new. I'm happy with, you see, that's why I'm laying the foundation. So if we start demoing now and I show you security group, it shouldn't be new because we've done it before, right? There will be listener rules, right? Where you can decide what you are listening to, which port are you listening to, and what should, attend to it, right? And then you can even have certificates. Like if you see many of the sites you go to, you can go to, most of them, you go to HTTPS, right? But behind the scene, there's a lot of SSL that happens there. You can do all that with the load balancer, right? Over time, you begin to see that logs, you can reveal logs, right, that are from your load balancer. And then you can also do things like draining, connection draining, to be sure that you can gracefully remove those EC2 instances, right? Especially be like during the maintenance period, just to make sure that the EC2 instances are not just removed abruptly, but they can gracefully be taken away. Okay. So I will stop at this point. So what have we done? We have introduced the 3 kinds of load balancing. I told you that 2 of those load balancers, the load balance traffic to your backend instances, but one of them does not do that. Rather, it load balances TCP traffic at layer 3 to a set of virtual appliances. Okay. So let's go to see what this will look like. Let's see. I'm here in my account as usual. Let me close this. I think I just have to close this. I'm here in my account. Usually, I usually use my, like I said, I use my admin account. Brainyl is my admin account. I don't use the root account for this kind of things. Okay, so sorry, I was meant to zoom in. That's doing printing. So where do we start from? So let's picture it. There is a user that needs to access a load balancer, and that load balancer needs to route traffic to the end users, right? Like we showed just now. The first thing you need to do is that, but again, the whole idea, you see me build these things, but again, if you come in here on like a builder's day on a Sunday, that's when you see me draw diagrams, because ideally, this would sometimes when you draw the diagram, it means you understand the concept and you can also reproduce it, right? So Sundays are really days that we can draw that diagram and you try to reproduce it from a diagram perspective. Okay, but let's go to a security group first. Security groups is here. Like I said, if you're looking for something, searching is just the easiest way to find those things, right? Okay, so I have a set of security group there, but I'm going to create a new one. So this is where I'll start from, right? So I'll call this a load balancer security. I'll just call it a load balancer SG, right? So usually you also need to learn how to just use terms for things. So SG is just security group. Okay, I'll say allows traffic. That's really what I want to use it to do. So allows traffic for my load balancer. Okay, balancer, right? So it's going to be in this VPC. I only have a default VPC right now. I told you with time we're going to talk about VPC, but right now we're still good. We'll be using the default VPC, right? Now I want to add inbound rule. If you remember, we said that I did like by default, all load balancer outgoing traffic, all security groups outgoing traffic is allowed, right? You basically just now need to decide who is coming in. So because it's a load balancer will be used from the outside, right? They need to access it from the outside. So because they need to access it from the outside, I need to make sure that the internet can access it. So I'm just going to add a rule here, and I'm going to say HTTP, right? Because if you go and type, right, I think we've also seen it. You can do HTTPS, you can do HTTP, right? So in this case, I'm going to say it's an HTTP traffic, right? Definitely HTTP is on port 80. And I'm going to say the source is anywhere, because my load balancer, as I've shown you in those diagrams, a user needs to reach it. So I need a way for users to reach it. So sometimes it's good to, allow users to reach my load, right, balancer. Good. So we have a security group here. It allows everyone to come in. It allows traffic to go out, right? I don't really need to create a tag. So I'll just create that security group. So we have a load balancer security group. Okay. I'm not going to create a new security group. Because if you look at that diagram that we shared, right, a load balancer is the one that reaches the EC2 instance. Okay. So people are reaching the load balancer, but the load balancer needs to reach the EC2 instances. Okay. So which means I'll have to go back to my security group. I'll create a new security group and call it EC2 instance. Let me just call it EC2 instance SG. Okay. So I'm calling it this. So allow traffic from load balancer to EC2, right? So here I'm saying that my users will not be seeing my EC2 instance, but I want the load balancer to be able to see my EC2 instance. Remember, EC2 is controlled by security group, right? Good. So inbound rule, outbound rule is fine. I'm okay for it to allow everyone to go out, right? But the inbound rule, I need to say custom TCP. I need to say basically the port should be 80, right? Because let's say the application that we're going to expose, as we've seen, is going to happen on port 80, right? I'm going to say custom. So this is where it gets a bit interesting. I don't think we've seen this before, but I think I've mentioned it on the slide that you can actually type a security group here, right? So instead of targeting an IP, you can say this security group allow another security group to access me, okay? So it's not just IPs you can use. It's not just, I think we've tried IPs on the call, we've tried CIDR on the call, but there's another variant that we're trying now. We're saying users be able to reach the load balancer be able to reach the EC2 instance. So I'm saying I want traffic. So I want port 80 traffic from the load balancer, right? So I would say allow traffic from the load balancer, okay? So sometimes these descriptions are good just for you to know what your SG is doing, okay? So I'm just going to leave it like this. So we've created two security groups. We've created two security groups. One allows traffic to come in to the load balancer. The other one allows traffic to go from the load balancer to an EC2 instance, okay? So what's the next thing? We now need to create an EC2 instance. So, but yeah, this is where it gets interesting. We need to create a target. So like I told you, a load balancer, users will reach a load balancer, and then the load balancer will go to EC2 instance, right? So that's like a target. So what it means is that we can actually go there and say target groups. Maybe we can try to create the load balancer so that you see where it's useful. So let's try load balancer. Okay, so we go load balancer. So we have a load balancer here. We created two security groups. That's the only thing we've created, right? Oh, we cannot even create a load balancer without an EC2 instance. So let's go and create an EC2 instance. Let's create an EC2 instance. So we'll do launch instance, right? So we'll launch. I think this UI is common to us now. So we'll call it my EC2. Call it EC2 instances, right? So it's EC2 instances. It's Amazon Linux. It's using Linux 2. I think we've seen this before. And the only thing is because we are trying to demonstrate the concept of load balancing, we probably will not do one instance. We'll do two instances. Most times when we create load balancers, we just use one instance, right? But in this case, we are going to do two instances, okay? And then we're just going to scroll down. For the most part, we don't need a keep here, right? Because this is not an SSH class. We've done SSH class before. So this one is not really about SSH, okay? Security group. So security group is where we choose the security group that we created before, right? So I think it's called EC2, which is good. That's one of the reasons why you should name your security groups properly, or name things in general. Just name things properly, okay? So here I'm saying use the EC2 instance security group, okay? For GP3, obviously I can use HGB GP3 volume, right? I think the only important thing is for me to put a user data script. The rest can be left as it is. We'll get to see them as we grow on the call. But I think I have an EC2 data script somewhere around here. I think we've done it before. I've done this before. So I'm just going to copy all this. This is just paste it, .it. We've used this severally on this call. So I'm just going to paste it. So basically I'm trying to install, I think if you've been on this call, you know what this is doing. We're basically trying to install HTTPD and then render this page as the home page, right? And then we have two instances. Let's just go back to our options. Sometimes I like to check. This is T2 micro, right? And then we're using this security group. For the subnet, we don't really care. You can trust in any of the subnet. We're using this, but good. And we say we want two of the instance. Linux 2 is what we are choosing. Cool. So my options are good. I'm just going to launch. So it's launching two EC2 instance. So let's give it some time. So if I go back to my instances, you see, this is, I think we are growing, right? Because the last time we've always been playing with just one EC2 instance, but now we're trying to launch two just to show the concept of the load balancer, okay? So we're just going to give it its time, let it run, and let it try to create, okay? But there's something I wanted to share before why that is creating. It's just the fact that target groups, right? So a target group is something that you need to know that it can stay on its own. So you will see that a load balancer needs a target group, meaning if someone visits this load balancer, where should I send the traffic to? But again, a target group can actually stay on its own. So you don't need to, it's just so you know. So for example, I think there is already one that I have here, but let's create one so that we can wait for the instances to load, but we can be playing with the target group while we're doing that. So we're going to do, this is where the target types comes in, right? So you can use instances, you can use IP addresses. The target group could even be a Lambda function, or it could be to another load balancer, right? You don't need all these details. In this case, we know we just want to balance, we just want to have a target group that can reach any of our EC2 instances, right? So we're just going to do that. We'll call it EC2 instance target group, right? So that's the name. So the question is, which protocol are we going to be reaching the EC2 instance from? That's where you decide. So here, it said the protocol for the load balancer to target communication, right? So which protocol? HTTP in this case, right? Because what we're exposing from the user data script is HTTP, right? So we'll say it's going to happen HTTP 80. It's not IPv6 but IPv4, right? We use the basic VPC that we have. We've not started talking about VPC. For now, it could be HTTP 1, like I said, HTTP 2. There's also other traffics. But in this case, we'll just stick to the default. Now, I told you about the concept of health check, right? Health check is just the fact that you can, usually the load balancer would always be doing periodic check to see if the instances that I'm trying to send load to, are they healthy, right? If they are healthy, good, I'll continue to send requests to them. But if they're not healthy, maybe I shouldn't send requests to them. So that's what health check does. In our own case, we basically just want to health check against, because remember, we don't have like an application. We're just doing something that opens like a home page, right? So it's really slash. It's like the home part. Just so you understand, let's wait for this. Let me see if these instances have already launched so that you understand what we're talking about. Let's see if, okay, so both of them are running. They finished status check. So let me just open both of them in two different tabs. So just so you know, we've opened both of them in two different tabs. The only issue I think is going to happen is that I can't even access them from the internet right now. I can't even access them because why? There's a security group that says only the load balancer can get to it. So right now there's no way I can even show you. But we can play around it. So I can temporarily just go back to this security group rule. Just so you know that that instance is already running. I can just edit this quickly on the call and just maybe for test. Sometimes you need to also do this just to test and verify that things are working fine. So I can say this is from 000, right? So from everywhere. If you're also on this call, you've seen us do this before. So temporarily allow traffic from everywhere. Okay. So just to test if the EC2 instance is actually working very well. Okay. So I'm just going to save these, and then I'm just going to look for one of the EC2 instance. So this one is here. I'm just going to copy the public IP, and then I'll try to open it first, just to verify that the EC2 instance itself is working. Let's see. Let me see. HTTP. I just want to be sure that I'm using the right traffic. Yeah, you see, sometimes you need to copy and paste because it looks like it always goes back to HTTPS. Okay, so it shows that the EC2 at least is responding to traffic. So it's here, right? So if we go back to this is instance 1, right? What about the second instance? So there, we check this one. This is 320429. What about the second one? This is the second one. So I'm just going to come here and do HTTP and paste it here and view. So you can see both of them differs, right? This one, this is the IP. This one, this is the IP. So it's good. It means that at least individually the instances are working and they are receiving traffic. So that's good. We just need to now load balance it. So I can go back to my load balancer. I can delete this. I've tested it works. So I'm just now going to limit it just to the load balancer to be able to reach it. Okay. Now that the load balancer can reach it, we were still on target group, right? So we're here. We know that the URL is at the home page, right? So we'll go back and say we want you to check against the home page. For advanced health check, healthy threshold, maybe healthy threshold is just to say how many, if I go there and check if it's healthy, how many times do I need to do that for me to verify that it is working as expected? Maybe I don't need to, I can leave it at 2, right? So that it can be fast. On healthy threshold, yeah, we can also leave it as whatever it is. Timeout, I don't really care about it. The interval is how often should I do it, right? For this call, maybe I'm just going to use like a small interval, right? So 5 seconds. So every 5 seconds, go and check it. But in the case of like the threshold, so in every 5 seconds, do it 2 times. And if there are 2 that are healthy, then it means if you do it twice and it returns that it's healthy, then it means that the EC2 instance is good, right? Status check is going to be 200, right? 200 is really a popular status code that says, everything is working fine, okay? And for the other things, I don't really need to care about it. I've already given it a name. I've said it's EC2 instances. I'm just going to go next, right? Cannot be smaller than the interval. Okay, we can use 2. It doesn't really matter. And then we go next. So now it brings me to target, right? You see that it tells me target because we've said it's EC2 instance. So now it's asking me for targets. And I know I have 2 EC2 instances. So I'm just going to say I want these 2 EC2 instances to be a part of that target group. And I'm going to say on port 80 is really where you're going to make the request, include them, right? So I'm just going to include them. So they've been included here. And then I'll create the target group. The point I'm trying to make here is that target group is independent of a load balancer. A target group is basically a group of targets, right? Group of target, meaning they at the back of that target group, there are maybe EC2 instances that somebody can reach, right? So it's here. It shows none is health on. It shows 0 on healthy. It shows 2 targets. Let me refresh this. It doesn't really show us much, and the reason is just because no load balancer is using it right now, right? So let's leave it as it is. I don't know why it's okay. Cool. So it's here. You can see it's unused, right? A target is there. We've created a target that needs to use two EC2 instances, but nobody's using it. So let's go and look for what is going to use it. So in the process of creating a load balancer, we can create a load balancer here. And this is where the option I was mentioning. So for application load balancer, you see HTTP, HTTPS, right? For network load balancer, there's really the concept of TCP, UDP, TLS, and it's like an ultra high performance load balancer. And the reason is just because it's not doing application specific, it's really not doing application layer specific things, okay? So it's very, very fast. And then if you ever think of something that would balance traffic around your network appliances, that's when a gateway load balancer comes in, okay? In this case, we want to create an application load balancer. So we're going to create one, okay? So I'm just going to call it EC2 load, I'll call it EC2, oh no, I'll just call it my application, because an application load balancer might not just be talking to only EC2 instance. So I can name it my application load balancer, right? Load balancer. Sometimes you need to name balancer. Okay, yeah. So internet facing, why not, right? That's the only way we can test it, right? We need to test that it's internet facing, but there are cases where you also want to do internal facing, right? So what it means is that internal facing means nobody can reach it from the internet. So I have applications that run like that where it's behind the load balancer, but you can't reach it from the public, okay? So in this case, we want it to be internet facing, we want it to be IPv4, okay? And then we can also go there and choose the subnets that we want. In this case, I'm going to use all because I'm not entirely sure where those EC2 instances were deployed. So I'm just going to use all the subnets that are there, okay? Now, this is where the security group comes in because it needs a security group now. And remember, I created one for an ALB, right? So load balancer security group, I created one. So I'm using that one instead of the default security group. Now, the listener, right? Remember an application load balancer, we said it listens HTTP, HTTPS. So here it's asking us for AT, where are we listening? We're listening HTTP, right? The question is, where are we forwarding it to? And remember, we created one just now. It is EC2 instance target group, right? So we're forwarding it there. Do we need to add a listener tag? No, we don't need to add. I think there's room for you to add additional listener. That's what I'm saying. So you can actually add additional ones. But in this case, we just want the traffic to go to EC2 instances alone. Tags, we don't really care. Like I said, as you grow in your journey, you begin to see that it's not just balancing to EC2 instances. There are more things that are happening. So you can integrate like a firewall to it. You can integrate like a global accelerator. There are many things you can do, right? But at this level, just you don't need to care so much about those things. So it looks like everything looks fine. I don't think I'm missing any other thing again. So I'm just going to do create the load balancer. Okay. So yeah, the load balancer is provisioning the load balancer, right? So we're just going to give it time. So before now, remember, we've been going here, like we've been typing the IP address, but we've said it that one of the reasons why you need to learn the use of a load balancer is the fact that you can't be sending your IP address to your users, right? To access your compute, right? Something more intelligent can do that on your behalf, and you also get the benefit of the fact that the load balancer can know when an instance is healthy and leave it in the pool. If it's not healthy, it can remove it from the pool. So there are so many benefits, right? All you just need to care is how can I reach the load balancer? And once you reach the load balancer, whatever is behind the load balancer, you can also reach them. Okay. So let's go back to our load balancer and see if it has created. It's still provisioning. Sometimes it takes time, but let's give it some time. Like you're aware, if I refresh this page, it's not going to work again because I've removed. It's still working. Interesting. Because I've removed. I thought I removed the security group. Let me be sure. Security. Just imagine I actually removed the wrong security group. When I was editing it, then I went to remove the wrong one. So that's why it's still showing. So I basically need to actually add the right one that says from SG, and I'm going to call it load balancer SG, right? So allow traffic from the load balancer. Okay. So and then I'm just going to save. But then maybe I can just now delete allow traffic from everywhere. So I'll delete this one and save this one and leave it like that. Let's check the load balancer. So let's go. The load balancer is still provisioning. It's taking a while. It has a set of target groups. So this is where it tells you your listeners, right? So right now we're listening on 80. And when you go on 80, what should you do? Forward it to a target group. And when you click on the target group, it goes to another tab where you can see the things that are within that target group. And I think we've shared it that, yeah, in this case, EC2 instance, right? So right now, I think it's showing initial, right? So target registration is in is in progress. So it means that the targets are being registered to the load balancer. That's what's happening here. So at least it looks like something is happening. We just need to give it time. Right now, it's still showing that 2 targets, 0 is healthy, 0 is unhealthy. That's because Probably the load balancer is still trying to do its work, is still trying to validate, if those instances are actually, if it can connect to those instances. But once it can connect, I'm sure that these things are going to change. So you can see it's showing that both of them are now healthy, right? So it shows that these two instances are healthy. So what it means is that two targets, two are healthy, zero are unhealthy. So how can we test that? If I go back to the load balancer now, there is usually if you go here, there is like a DNS name, okay? So if you DNS name, this is the DNS name. So it's an A record. You just copy. So copy would have just saved me the stress. So paste, and it opens. So it's here. So if I refresh, over time you can see that the IP addresses are changing, right? You can see it's changing, right? So it shows that one of these instances, the different instances are actually getting the traffic. So it switches from 6.6, it switches to 13, right? So what do you think is going to happen? Like, remember that if I go back to the EC2 instance directly, I can't, right? Because the way the security group works right now, you can't really reach the instance. So the only way you can reach those instances now is using the application load balancer, right? So when you refresh, it goes there. And then what else can we do? So if you go back to the EC2 instances, there are two of them, right? So there are two instances running. So what happens if we terminate one of it, just one of the EC2 instance? If we terminate one, so let's just terminate one of the EC2 instance. Terminate it. We're terminating the instance, it's shutting down. While we are terminating it, let's go back to the target group and see what will be happening. So if we refresh, let's give it time. So on the left, we are terminating one of the EC2 instance, and then on the right, you can see immediately, because there's an health check, you can see it says one is already unhealthy, right? So it's here, unhealthy, right? So health check has failed, meaning it couldn't reach the home page of that EC2 instance again. So request has timed out, But the question is that what about here? What will be happening if you refresh, 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 refresh? Only one EC2 instance is now going to be sending the traffic, right? Just one, because one of them has failed. So the load balancer is smart enough to know that one of the instances is out of the pool, and it's wise enough not to send traffic to it. Okay, so that's exactly what is happening. Then after a while, it's going to take out that instance. So you can see when we came back, that instance has gone. Okay, so it's worth noting. Cool. So let's go back to our slide. So I'll show you one more slide, and then we should be good for this. So one thing you should notice is with that load balancer that we just created is that, so what we just shared is similar to how a network load balancer also works, right? It's just that there are places where it is more applicable for you to use a network load balancer as opposed to using an application load balancer, right? So like I said, if you go back to this, I think we've looked at this before. Security group was involved. There was a security group involved. There was a listener rule that was needed, right? We needed to say, if you go /on80, go to this target group, right? So TLS, we didn't talk about that. We don't really need it. Now, this is the last concept I wanted to share. At this CCP level, you don't really need to go into details. But one thing you will need to know is that when we created the EC2 instance, so let's go back to the EC2 instance. I know we've terminated one of those two, right? But let's go back to the one that was terminated, and let's see. So if you see those two EC2 instances here, one is in terminated state. The other one is not terminated. Well, right now, I can't really, surprisingly, both of them were actually launched in the same availability zone, right? Pretty much because I did it in one go. I did two instances at once, right? But ideally, maybe what I would have done is to put one in US West 2A and put the second one in US West 2B. But just so you know, there's a concept of cross load balancing, which means that the EC2 instance, the load balancer, although it is in a particular, it has like instances in an AZ that's supposed to route traffic. That traffic is still going across the AZs. So it means that the concept of cross load balancing is just the fact that regardless of the AZ in which you are reaching the traffic, it can also route traffic to instances that are in different AZs. So just so you know that the load that comes here from the UI might come in from a particular availability zone, but the target, which is the EC2 instance that's responding to the traffic, could be in another availability zone. And that's just the concept of cross load balancing, which means the load balancing is designed in such a way to more or less like move your load across different AZs, right? It's enabled by default. Okay. I just wanted to add that as part of the slide so that in your journey, just know when you hear cross load balancing, it's just basically the fact that traffic can still move from one AZ to another AZ, right? And then you will see that for an ALB, it is enabled by default, but for network load balancing and gateway load balancing, they are disabled, and there's a reason for that. But I don't want to stress you with the details. Just so you just know that cross load balancing is the fact that although the load balancer has something that is listening and managing the traffic at an AZ level, but it is designed to also send traffic to a different AZ, okay? If there is need, if there is need. And I think it's a good segue for today's class. I wouldn't want to stretch it beyond this point. So we've shown, introduced the concept of load balancing, the three types of load balancing. Network load balancer, just at this level, nobody's expecting you to create one. But sometimes this concept is good for you to basically try to internalize it, right? By creating, by doing, right? Because if I was just to teach you about load balancing and you didn't really see it in effect, and as you're aware, Sundays is really where you come in and do yours, right? Because once you can internalize it, once you can build it, once you can see it work, it becomes very easy for you to understand the concept and and be able to relate with it. So that's a good way for us to end. That's like a good segue to end today's class. Now it's time to tear down everything that we have created as part of this call. Okay, so we're just going to go back to the things we created. So we did create, first of all, we created a target group. So we can go back and clean up our target group. I think it was this one. Let's just terminate it. So we can delete the target group. We can just delete it. Is in use by an instance. So maybe we can start from terminating the instance first. So let's terminate the last instance that is still running. So let's just terminate. Let's terminate this instance. Let's give it some time to terminate. So the EC2 instances were the ones that were we were using to route traffic, right? So we were using to service the traffic from the load balancers, right? So these two instances were taking traffic from the load balancer, and these two instances were part of the target group that we created. So here we're just trying to shut down and terminate the EC2 instance because just to clean up, it's always good to clean up so that you don't. So it's still shutting down. Let's go to the target group. So the target group, we created instances. If you remember, the target group is really where we decided which EC2 instances were part of the target group. So right now there's still one, so we're just going to remove it. Although it's even unhealthy, but we can just deregister it. So we're going to remove it, and that will give us room for us to delete this target group. Although I think it probably won't delete because yes, it's currently connected to a load balancer. So let's go back to the load balancer we created. Remember, the load balancer is what the users will see. When the users see it, depending on the rule that you have created, it chooses a target group, and the target group is now what leads the traffic to those EC2 instances. So we've terminated the two EC2 instances. The target group we cannot. We have to go to the load balancer. So let's go to load balancer here, and then let's remove the load balancer. So the load balancer we created is my application. I think it's my application load balancer was the one we created. You can actually go in there and see the listener. So there was a listener rule that forwarded to a target group. We're just going to more or less like just delete the listener. So we confirm by deleting the listener. And we just delete it. So once the listener is gone, we can actually now delete the load balancer. So we can delete the load balancer. We click confirm. We'll delete the load balancer. Once the load balancer is deleted, I think now we should be able to delete the target group because it's now no longer attached to any load balancer. So we're just going to delete this one. It's gone. I have another one that is here that is not doing anything. I'm also just going to delete it. So we're good. What else do we have? So now if we go back to the URL we're using before, it's gone. It's not going to open again. What else? I think we also created two security groups. So let's go and look for them. So we created two security groups. One of the security group was to allow traffic to the load balancer. So it's this one. So we're just going to delete it. We don't need it. It's still either, what is it saying? Okay, let me just hope. Let's delete the security group. I think, oh, okay, yeah, because we created an association, it's not going to allow us. So let's look for the other security group that's using it. So if you remember, we created two. One was EC2. The EC2 security group allowed traffic from the load balancer security group. So we have to delete this one first. So let's get rid of this one first. If this one goes, then it becomes easy for us to delete the load balancer security group. Okay, so sometimes you just need to go back to your account and clean stuff up. Many of these security groups actually don't need them aside the default security group. I'm just going to get rid of them and enter delete. So just going to delete this one. So always be in the habit of cleaning things up, especially things you are not using. Just delete them. Let's see. Launch wizard 3. I can let that one go. I don't know what it's complaining of, but I don't really. So instances is terminated. So our instances are terminated. Cool. We should be good now.